In this session, I would be talking about different ways of working with input data in R. How do you input the data into R? What are the different mechanisms, right? How do you read different kinds of files into R? So that is the major objective of this session. So getting in, we would try to see how do I get the data from the keyboard, what are the different kinds of functions that I can use where I can get the data from the keyboard into R. If I want to get the data into R from different files, let's say a CSV file, how do I, or even a text file, how do I get that data into R? So that is one more aspect that we are looking at. Then some important functions will spend some time. Scan is an important function to get the data into R. So we'll try to use the scan function. Similarly, I can read the data using this function called readLines. So how is it different from scan? What are the advantages, disadvantages? In the meanwhile, we will also talk about a few other functions called read.table, read.csv, some other functions which can help me to read the data from different types of files. Then, what do I really mean by attaching the data frame to R? What happens in it? What are the kinds of limitations when I attach? What are the kinds of warning signals that I get when I attach my data frames in R? Within that context itself, we'll spend some time trying to understand what is masking. And regarding all these data inputs, some of the important points to remember, right? We will be discussing a few important points while getting the data into R from any of these input sources. Then we talk about the different kinds of data files. So which are built-in data files in R. As a part of the base R, there are some kind of data files. As a part of various packages that are installed along with R, there are some kind of data files. So how do I really read those data files and how do I access those data files? So one more aspect going into it. Then how do I really play around with the paths of the files? If I have to set a specific path to a file, what are the different ways in which I can do that? And towards the end, our focus is getting the input data from an external database. How do I connect to that external database? How do I make sure that R is able to read the data from that external database? So we'll take the help of an access database. So we'll try to see how I can really read the data from an access database. So these are the different kinds of ways in which you can get the data input from external sources into R. So the whole session is more dedicated towards that aspect. Now, if my variable has a very few values, then I can very well use the concatenate function itself. So parallelly, let me start using them. So I'll create a variable called x where I will assign it some set of values 20, 5, 3, 15. So if there are a very few set of values, I can very well assign them to a particular variable called x using the concatenate function c with just straightforward work, right? So if I have a single variable with a very few values, I can very well resort to this kind of an aspect. But if I have slightly more number of variables, then I prefer going ahead with a scan. Now what does this scan do? If you see, it allows me to type values from the keyboard. It says 1. So you enter the first value. Okay, first value is 5. Second value is 6. Third value is 3. Fourth value is 10. Fifth value is 45. Sixth value is 24. Like that I can keep on entering the stuff one after the other. So this could be one more process which I can rely upon. Scan is something After that it said read 6 items. So scan is primarily another function that I can use if my variables are of intermediate size. Very few means I can use concatenate. Otherwise I will rely on scan. And if I have much more bigger, larger data sets, then it's better to use read.table. So which means the data set, let that be as a part of a spreadsheet, which would be understood by Excel as a data frame, and read the values from that spreadsheet or a .dat file, some external file. You create the data in some external file and try to read that using the read.table function. So we'll use the read.table function, but wherever it is, we'll use the read.table function, especially if your data set is too large with good number of variables. So these are the three broader ways in which I can get the data from external sources into R, out of which read.table and a lot of variants of that read.table which we will be looking at, like read.csv, etc. Those are the ones that play a very important role in reading the data from some external file sources. Now, let's get started with getting the data input from the keyboard. We have already said we would be using the scan function. I have already implemented it, right? I have typed in the first few numbers into a vector from the keyboard, and after the at the one prompt that I have got, I have entered my first number, enter key, and I keep pressing it, and after, let's say I got 7, I have no more values to enter, I press enter once again. That is sufficient for me. Finally it says it has read 6 items. That's the way you typically end your final entry, also using the scan function. Now the other advantage of a scan is I can directly do a copy paste from my Excel sheet as well. Let's see this. Let's say I have opened up some Excel sheet, right? Within this Excel sheet, let's say I had a set of values, right? Let me say 1, 2, 3. Let's say I have a set of values here, right? Or probably let me put 10, 20 here, right? Let's say these are the values. Now let me call Z as a variable, which I am giving it as scan. Now at 1, either I can type it directly from keyboard, or I can copy this. Right now this data is copied to a clipboard. I can come here and I can do a pasting. Now you could see 1 to 10 have been assigned already. Now if I want to paste these things, again I can do a copy. I can come here and paste. If there are no more, I can very well do an enter. So either I can directly enter the stuff, or I can do this kind of stuff. This is what I was mentioning here. In the spreadsheet, I'm highlighting the column of numbers that you want, then copy that, and at the one prompt in R, paste it. All the numbers will be scanned in one single go. So if I have few more ranges to be pasted, do the same thing, and finally you press the enter key, and that will complete your data entry process. But let me tell you here, my data should be in the form of columns only. If my data is in the form of rows, I cannot typically copy it. Like this, I cannot copy and paste it. Right? So there's one word of caution when you are copying and pasting things from your Excel sheet into R. You have to copy the stuff only in columns. So if at all your data is there in the form of rows, do a transpose of that and then copy it from the columns itself. So this is one important point that you have to remember if you are especially copying the numbers from a spreadsheet. Then The next important point which we are talking in this context is how do I get the data input from the various files. The first thing is make your data into the shape of a data frame. We know data frame is nothing but it is m by n kind of a table kind of stuff which has m rows, n columns. N columns are like n headings, n variables are there as a part of the columns, and m cases or records are there as a part of the rows. So anytime it would be better if I am trying to get the data. So the easiest way is create a data frame, whatever is your data, try to convert it into a data frame and try to read it into the R. So each variable, put them into a single column, right? All the variables, whatever you have, all the data relating to each of the variables, put it in a single column and put a heading to that particular variable. So we say typically when you are talking about an m by n kind of a table, m records or sometimes we call them as cases, and the columns which we are where we are putting headings, we are calling them as variables, right? So you can very well read the data from a spreadsheet into R as a data frame. If it is a data frame, you can very well read the stuff into a data frame quite comfortably. Especially if your data is in the form of a spreadsheet, you can comfortably read it into R as a data frame. But let me tell you, if you have a text strings containing blanks, right? Probably talking about city, New Jersey. So this is typically having blanks. So if you have some kind of text strings containing the blanks, we'll find that the read.table is not a good is typically not a good function to use, because the number of data items, let's see this, let me create one simple file like this. Okay, the same, let me create this file here, serial number, so I'm putting a heading with a space, right, then marks something. So I'm saving this, right, let me put it as a CSV file, on my desktop. I'm calling it as test. Okay. Now I want to read it. So let me go to my desktop. So this is the one. So I'll access the path of this. So let's say read.table, and I'm putting the path of this like this. And in case of Windows, instead of a single slash, I'll use double slash. I'll talk about it as well. But this is the way we read the table from Windows. Now you could see line 2 did not have two elements because there is a blank in the first one. So when there is a blank in the data, you see that it can't read the stuff, right? Probably just to make a difference, let's say instead of this, let me put a dot here and save the file. Right now I have saved the file by putting a dot at the same time. I don't have the blank. Then if I try reading it again, it gets read. You see, serial number, comma, marks, right? So I'm able to read it. Now one more thing I can set sep equal to comma, which talks about the separator is a comma. So then immediately you could see serial number, marks, and it is showing 1 to 10. So because the separator is a comma, so it separates the data based on the comma and produces me the result. And at the same time, I could say header equal to true, so that this becomes my heading rather than new headings called V1 and V2. So I could even set header equal to T for the same thing. Then this itself will become my headings, and these are the values. So one thing that you could make out here is when you have text strings containing the blanks either as a part of the headings or as a part of the data, then I can't use read.table unless I convert all those blanks as dots. So do a find and replace. Wherever the blanks are there in the middle, I should convert them into a dot or an underscore kind of stuff, and then only I would be able to use the read.table command. But if my data is in the form of a spreadsheet, in the form of a CSV file, sometimes it's better to go with read.csv kind of a command, which is executed in the same way, right? If you see here, I can use read.csv, just specifying the path of the file, nothing else. I can simply specify the path of this file, read.csv. It will simply read the stuff. So read.csv is more sophisticated if you are trying to read the data from the spreadsheet or from a CSV file rather than using the read.table. But read.table is good as long as your data contains the numbers or even the text, if that particular text does not contain any kind of blanks. When I say blanks, even the space between the two words within a single cell also should not be present. So the input fails because the number of data items does not match the number of columns. So only when the number of items is matching with the number of columns, then only the read.table becomes usable for reading the data from a text file or from a spreadsheet into R. Then the next aspect that we are talking of here is working directory. So working directory makes accessing and writing the files so much easier, because every time I don't need to give the full path. If you see here, this is what is my full path of the file. But if I set something up to here as my working directory, right? If this is what I set as a part of my working directory, then from the next time onwards, I can simply specify the name of the file itself. So I can avoid typing this entire path every time, and I can very well save some time or save the possibility of the mistakes in terms of typing the entire path. So the way I set the working directory is using the set wd command. So I can set a specific path. Get wd command will give me the current working directory path. First, let me find out what is my current working directory. I use get wd. So it says my current working directory is c:/user/prajna/document. So this is what is the current working directory. Now if I want to set this to this particular location, right, my desktop, this is what I want to set my working directory as. What is that I can do? I'll say set wd, which is my set working directory, wherein I'm giving my path. So this is what I'm setting as my Oh, sorry, I have two double quotes here. Let me give only one. So this is my working directory. Now if you look at my get wd, now my working directory becomes this one. So there is a change in my working directory, right? So from now onwards, whatever I'm doing, it gets saved to my current working directory itself. Now, if I want to know what are the different files that are present as a part of my working directory, then I can use the dir. Dir is the directory. So if required, I can get the directory of this path. I can give this path saying out of this path, get all the files that are present in this particular path. So it gives me these are the list of the files that are present in that particular path, right? So I can very well get the list of files in a particular path using the dir. And if at all I have to pick a file from the browser, right? I don't know the name of the file. So I want to read that specific file. So what is that I can do? Let's say I want to do read.table, but I did not remember the name of the file. So this is where I say I can set it as file.choose. The moment I set file.choose, wherein I will be opened up a browser, and from that browser I can very well look at the names of the files. And once I have chosen the file, I'll simply try to display it. So that's where I'm saying header equal to true and probably sep equal to comma, because this is what I'm trying to read from a comma separated values file. So once, because I have used in file.choose here, it will it will try to open up my working directory, and based on this working directory I should be able to choose a particular file, right? Then I should be able to choose my file. This is the test file that I have chosen. So the moment it has read it, you see that it has displayed it like this, right? So generally file.choose is typically if I want to read a file from my browser from a particular folder or a directory, generally we combine it using the read.table. So this is one more way of reading the stuff into R. Then another mechanism wherein I can use the read.table. So I'll look at some kind of a text file and I'll read it into R. So as a part of my folder, I could see here, let me set the data as, so let me give my location, read.table, right? Either I'll give the whole path. So this data are present as a part of my H column, training videos are data sets, and within that I want to look at a file called yield.txt, right? This is the name of the file I wanted to access. Okay, because it's a read.table, or it is yields.txt, and because it is read.table, I will set the header equal to true. So now if I look at the data, so this is what is the data, right? There are 10 rows, 3 columns, sand, clay and loam, and these are the values that are there as a part of this yields.txt, right? Now here in this case I have read the whole file, and by setting header equal to true, it is putting these first row as the header. In some cases I can simply put read.dlim. So when I say read.dlim, the header is simply omitted. So instead, if I say data1 read.dlim and I use this file name again, I don't need to set header equal to true for that. So I'll say read.dlim, and if you see data1, I'll get it exactly in the same way. So if I want to omit the argument header equal to true, I can very well set read.dlim as well. Now let me tell you a few things. There are some kind of errors that we make when using read.table. We have already talked about any kind of spaces either in the headings, variable headings, or even in the data. Anywhere if you see some kind of spaces, so either in the row 1 or between any of the words, I could see that there is the possibility of an error. The system would not be able to read the data properly, right? And if that is the case, either I should be able to find and replace all the spaces with some other notation, right, before I really get it into R. And whole path, right, when we are giving the path overall, the entire path needs to be enclosed in double quotes. And it's when you are using read.table, if you set header equal to true, then it means that the first row contains the names of the variable that will act as heading. In Windows, always use this kind of a format when you are giving your file path. Rather than a single slash, give double slash, right? Data file contains black spaces when there are missing values. Make sure if there are some missing values in your data, replace them with NA, right? All the missing values, try to replace them with NA, not available, before you read them into R. Otherwise, it can create some kind of a problem. So the final version of your read.table should look like this. Read.table, the path of the CSV file or the text file, the full path, or if you have set your working directory, the path after the working directory, header equal to true, saying that it is you have a header row, and sep equal to comma, setting that you are getting a CSV file into R. In some cases, the sep may not be with comma, it might be something else. But if it is a CSV file, compared to using read.table, I suggest that you should use read.csv because you don't need to set header equal to true and all those kind of things when you are using read.csv. So that could be the advantage that you will get while using read.csv. Then, talking about different kinds of separators, right? In case of read.table, the default separator is a space. So wherever it is finding a space, it will take it as a new column, new variable. But if you have comma separated fields compared to using read.table, I suggest that you should use read.csv. But if the fields are separated by semicolon instead of comma, then use the function as read.csv2. And when you have tab delimited fields, the fields are separated based on tab, then you use read.delim2. So these are all similar kind of inputs, right? They are separated by different separators. Most common one is a CSV file. So for that CSV file, you can read that CSV file into R using the read.csv. And if you want to specify the row names, right now if you see when you have read the data, it is putting the names as 1 to 10. If you want to put some kind of row names, right, either this column values or this column values or this column values, you want to put them as row name, then one of the columns of a data frame, so it could be one of these three columns, it should be a vector and the values need to be unique. So here I don't see any of the values to be unique. So if at all any of the values are unique, here it's not. So if at all any of the values are unique, I can very well use those values as the names of the specific rows. But otherwise, the system will typically assign 1 to 10 or some kind of a auto number as a serial number for giving the names to the rows. And default behavior of read.table, right? If you are looking at read.table, the default behavior of it is, if at all there are some character fields, they are automatically converted into factors, right? We can simply look at that. Let me open up the let me open up my desktop file again, the test, right? The same text file, let me open. So I'll put one more column called category. So let me put D, 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 C, 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 B, B, and A. So this is the kind of categorization that I have done. Now I am reading this data. I have saved it, right? Now let me read this data into R. So let me read this as a table, right? Let me do this function again. Read.table. So this is how it has read, right? So you could typically look at the structure of this read.table. Either I can assign a variable for doing it. So I can say marks as the name of the variable, wherein I'll do a read.table of this. So I'll look at the structure of this marks. I could see here serial number is an integer, marks is an integer, but category by default is a factor with 4 levels A, B, C, D. So A is assigned a value 4, right? B is or A is assigned a value 1, B is assigned a value 2, C a 3, and a D a 4. So that is what is the kind of assignment of the values that has been done. So by default, when you are trying to read the data from a CSV file or some other location into R, all the categorical variables, right, character variables, they are converted into factors. But if I really don't want them to be converted into factors, then I should simply use as.is. Now if you see here, in the same thing, if I set as.is equal to whatever is the name of the variable, I have to put it as as.is. So as it is, you keep it. Don't convert it into a factor. Now if you look at the structure of marks, you could see that the marks is being shown as a category and not as a factor. So as.is will keep it in its original order itself rather than trying to convert the order of it. And in some cases, if you want to get the data directly from the web into R, still you can use the read.table. You just need to give the path http slash double slash, right, the name of the website slash, finally it should go to some xyz.txt. The whole path of it you give in this way. So you are combining the domain name along with the file path. So based on that, you can get the data directly into R. But of course, here you are not using backslash. You are using the forward slash to separate the folder and the file name. So this is the way if you want to really get the data from a website into R. So these are the different processes that are there to get the data from different kinds of files into R for doing different types of processing, for doing different kinds of analysis, right? Now, let's try to understand a little bit more about getting the data from the files using scan. Earlier we were trying to get the data from the keyboard using scan, but now we will try to use the scan to typically get the files from to get the files to get the data from files into R. We have already discussed that read.table is very good for data frames. Data frame is exactly m by n kind of vector where you have m rows and n columns. So all the columns have equal size. So in that case, we are calling it as a data frame, and read.table or read.csv is more appropriate for getting the data, which is in a form of a data frame. But if you have different lines with different number of fields, then obviously we are not able to use the read.table. Let me just use this example. If you look at this data file here, right, you could see that it is having not equal number of rows and column. It has 5 rows, but one row has five values, one column. The other column has only 3. The third and the fourth columns have only one value each. So not all columns are of uniform size. Now if I have to read this kind of data into R, right, probably let me see if I have to read this kind of data into R. Let me call this whole thing like this. So here I don't have headings, so let me not take the headings. And this is what is the name of the file RT in that same location. So if I'm doing this, reading into data file, it says that it's an error, right? The line 1 does not have 4 elements, because at the end I have here 4 elements maximum. So each row should have 4 elements, and what I could see is the row 1 is not having 4 elements here. So which itself says the read.table cannot work if the lines have different number of fields. Now this is where we are talking about different kinds of alternatives, out of which now I am going to look at the scan. The other one I am going to look at is readLines. So we'll talk about these two kinds of functions which can help us in terms of reading this data. Right, read.table has given an error. Now when I am using the scan function, it is reading the data into a list. When we are saying it's a scan function, it is the reading the data into a list when it is used to read from a file. So I can read it into a list. Now if you see here, right, if I say data and say scan, this scan, it has read 10 items. So scan, when I am doing it something like this, it has read the data in the form of a list. And if you look at the word data here, you could see everything has come in the form of one single line. And if you want to look at the class of data, it is coming out as numeric because it has read it as a single vector. Now, it is less friendly for reading data frames, but if my files are more and more non-standard, then it is more easier to read them. And by default, it assumes that what you are inputting are double precision numbers. But in case if you are, so here they are all numbers itself, so it did not create any kind of a problem. But in case your data was not containing numbers, it is containing text, I have to specify using the what function what exactly you are inputting. So I may have to give what equal to, let's say if the same thing, if it is not numbers, let's say all those are characters, Then I have to set it as what equal to character. If I do this, then if you look at the data, everything comes in the form of a character. Because I've given what as a character. By default, it assumes that everything is a number. But if I say no, they are not numbers, they are characters, I have to specify them using what. And the scan expects to read space delimited or tab delimited input field. But if my input fields are something else, let's say comma delimited or dot delimited, I have to specify the other option, separator option. So I have to specify it as sep equal to something. And the moment I set sep equal to slash n, so it is assumed that one wants to read entire line verbatim. Now if you see the same, instead of this, okay, let me remove the what function here, what argument here. I'll set the sep equal to, I'll put it as slash n. I'll put sep equal to slash n when I'm doing a scan. Now it read 5 items because the whole row is read as one single item here. You look at data here. So 138, right, the first one. 2744, the one that are there in the second row, all of them are combined and read. Spaces are all ignored. 192, 0, 3, 4, whatever, all these 19, 20, 345, 48, all of them are read into one single. So when I'm giving sep equal to slash n, that is the way all of them will be clubbed together and read. But at the same time, if I give sep equal to slash t instead of slash n, now it has read 20 items. If you look at data here, it has said 138, NA, 2744. All the data would be read correctly, but it would be treated as if there are 4 columns for each one of them, and I can typically get the values for each one. So wherever values are not present, I would be getting the NAs in their place. So that's one more way I can get the data as a part of the data frame as such. Now in some cases, if I have to read the data from the data frame itself, right, let's say I have one more data file. I have something called worms.txt, right. I want to read this one. I want to read this file as a part of my scan. Now within this, there is a heading row for me. So I want to skip the heading row. So this is where I said skip equal to 1. Now when I do this, so scan expects a real got nashes.field. Okay, so here you don't have scan expects everything to be numbers, but here there is some textual data present. So this is where you are talking of what you have to specify it as what, right? So you would clearly give what, let's say you call it as a character itself, right? Everything you treat it as a character, or you can very well specify everything to be a list, right? That would be much more better. Instead of specifying it as a character, you can set it as dot list. The entire thing you can set it as a list. You have 7 different columns, so that's where I will set 7 different spaces. So I'm repeating it 7 times, this 7 different spaces as a part of this exercise. So I'll close the bracket here. So 20 records have been read. Now I can look at what the data is. Now it comes out as 7 different list elements, right? So there are 7 columns of data. So I'm specifying 7 different fields of character variables. So this is what I have put this as a character variable. And because there are 7 different characters, I have set everything as a list. so that all 7 characters are separated. If I have given what equal to character, all 140 would be read in one single shot. But if I am giving it as a list of 7 different groups, each group will be understood as a separate character string. So that's where I have given 7 different repetitions of this, so that 7 different lists would be created like this, right? So I have typically got this, and if I want, I can convert this entire thing as a data frame as well, right? So I'll call this as data1. I'll call it as .data.frame, converting it into a data frame. Now if you look at data1, everything is converted into a data frame for me, right? So I have got the list, I'm converting it into a data frame. So there is a way out where I can convert the stuff. So skip equal to 1 is skipping the header row. In some cases I can set multi-dot line equal to true, especially when a record is occupying more than one line. I can say multi-dot line equal to true. So all these different things I can very well perform using the scan. But let me tell you, if it is a data frame, it is very much better to use read.table or read.csv rather than relying heavily on scan kind of a function. The same input I can talk of, the same mechanism I can talk of when I am trying to use readLines, another kind of a mechanism, right? So if you see, I am using a line as the name of the variable. Let's say I'll do a readLines wherein I'm referring to that same H training videos are datasets worms.txt, right? I'm setting this read line. Now what happens is every line is read separately. You look at the line. Now every line, the whole line is separate, is read as one single input unit, right? So let me look at it. Each line becomes a single character string. This is how it is. If you look at the class of the line, it looks like a character string for each line. So that is how every line. So if I want to convert this into a data frame, first thing I need to do a string split by where I put the separator, right? So if I say this particular line, I have to put a separator. So because I got a line, I'll say string split, the entire line, you do a split, right? You are doing a string split of the line where all the slash t's, slash t is your all the tab marks are typically getting based on the tab, because the data wise it's separated through a tab. So using the slash t, wherever slash t is coming, you are doing it as a separation. So you will get it as completely separated. Wherever slash t is found, the whole thing is separated. If you want, you can save that piece. So string split is stripping out the separators from the data entries. Then, because these are all lists, so there are 20 elements of the list. So the other thing is now 21 elements. So you should unlist it. So if you have to unlist it, the same thing, you do an unlist, right? Because it is in the form of a list, I can very well do an unlist of this. The moment I do an unlist, this whole thing is removed in the form of a list. It comes into the form of a vector. So now the whole set of elements are coming in the form of a vector. Now I can very well define the size of the vector, right? The entire thing is coming in the form of a vector. Now I can very well define the size of the vector using a dim, right? So the dim of, probably let me call this entire thing as some variable, right? AA, I'm calling this. So I'll say dim of AA. Let me set it to, because there are 147 elements altogether, right? So I'll set it as 7 comma 21, wherein I'm setting it as 7 rows and 21 columns, right? I can set this as 7 comma 21. Then if you see, I'm getting if you look at AA, now they are coming out as 7 columns, 7 rows and 21 columns. If you want, I'll set it as T, right? When I said T of AA, the same thing is getting transposed. So I can very well work it out like this, and finally I can save this as a data frame. So as dot data dot frame, I'll say T of AA. Of course, some small modifications I can very well do. Right, so probably this thing itself, I could have removed the first row, and after that I could have set this as the names of the headings itself, right? So probably otherwise, let me call this as dot data dot frame as AB. Right now this is AB, so I could very well set names of AB. I'll set it as the first row values itself, right? So AB, the first row values, the row number 1, all the columns. So if I'm setting it like this, now you could see AB, you get the headings, field name. Now what are the values coming out here? AB is coming out as field.name, the headings are coming out from AB, field name, area. Okay, let me again set names of AB. What is coming out? They are coming out as 520, but yes, if you want, I can very well set names of AB. Let me take the names directly. Field.name. Then I can take area. Then I'm setting it as slope. Then vegetation. Then this one. So I'm setting these names at least. So let me just check now. AB, yes, these are the headings that are coming out. Now I can very well remove from AB, I'll remove the first row, right? I'll take all the other rows and all the columns. So now if I set my AB, it is being set exactly like this. So I can very well adjust the stuff, but remember, this entire thing is an effort. So converting it into a data frame using the readLines command, especially if it is a data frame, it becomes more and more pathetic. But if I'm using readLines to read, if I'm using readLines to read my original RT, then it could be slightly better off itself, right? There I can do the strippings. If I'm talking about read lines of rt.txt, which was this text file, which is whose size is very much not the similar, so there I can think of using the read lines more effectively, just like let me say here if I am reading rt.txt, now I could see line is coming out like this, right? And based on this, I can even talk about string split on this line, wherein I am identifying /t. So at least it comes out as 138 and space space 2744 space space kind of stuff. So I'm getting at least all the values are present. There is a separation that is happening based on these things, and I can do a string split for every of the things, and I can even perform as numeric kind of stuff. So I can very well apply the things for every line if I want. So string split function for the whole thing, if I am applying, I can very well get the data in this particular form. And after that, I can very well convert each of the things as a numeric and all that kind of stuff. But yes, but one simple thing that I could see in the whole process is uh, wherever comfortable, it's better to use read.table or read.csv if your data is more and more of a tabular kind of a data. Alright. Next, in some cases, if I am working with data frames, right, I try to attach the data frame. So let me talk about getting one data frame. Let's say I'm having one data frame called murder. So which I'll use read.table to get it. So it is there as a part of my training videos folder, wherein I have R data sets, and within that I have murders.txt. Now the point here is this particular file, I'll set header equal to true, and here, okay, let me set header equal to true. That's it. Now if you try to look at the first few lines of this murder, I can do a head murder. So there are a few things: state, population, murder, and region. So these are the four. Now murder is the name of a column, murder is the name of a variable. Now if you start attaching, what is the meaning of attaching? I'm setting the variables inside a data frame wherein they can be accessed directly by the name. Now let's say if I have to access the murder here, or if I have to access the region here, I have to call it as the name of the data frame murder dollar the name of the variable, which is region. I have to access it like this, right? Or murder dollar murder. But if I do an attachment, so when I say attach murder, it means I can avoid this step. To access the region, I can directly say region. That is the advantage. I can directly access by their name, and because the data frame is attached to the entire R search path. Otherwise, I have to give this is the way to access the variables from a data frame. So because of that reason, let's say I want to attach this variable, this name of the variable called murder. Immediately I'll get this error. The following object is masked by the global environment murder. Because the name of the variable, the name of the column, and the name of your data frame, both of them are the same, and you are attaching this. So when you are using it at a later point, the system does not know which murder you are referring to. Is it to the entire data frame, or is it to the variable that is present inside the data frame? Now this is where we'll get this kind of error. So there is a duplication, one for the name of the variable and the other one for the name of the data frame. So that's where one of the suggestion is give a unique name to the data frame. Let it not overlap with the names of the variables within a data frame. So when you are attaching a data frame, generally we suggest not to attach a data frame, but if at all it is required that you have to attach a data frame, give some kind of unique name. So one more thing, so that is what we call as masking. So the same name, if you are having different variables with the same name within a single session, where the meanings are completely different. Especially if you use some simple variable names like x, y, z, there is always a possibility that you use them for different kinds of purposes. So it's always better that if the vectors are sharing the same name, if they are of different lengths, at least R will give you some kind of a warning, or R will stop doing the further processing as a part of your model building. But if they are of the same length, R cannot really make out what is your intention. So it will simply give the proceedings, and you may end up with erroneous output altogether. So a few suggestions in this context are, whatever are the names of the variables that you are giving, give more and more self-explanatory names to the variables. Let them not be a simple variable names like x, y, z, etc. Use them as much longer as possible, right? Let the names be more and more self-explanatory in nature. And variables, don't do the calculations if you have having the name of that particular variable as one of the headers in a data frame. Don't use the same names as a part of your variable calculation. Make sure that those names which are the headers of the data frame, column headers in a data frame, those names are not repeated. And whatever are your calculated variables, if you have used any kind of intermediate calculated variables, so once you are finished with your calculation process, try to remove them using the RM function. And finally, one of the important suggestions is, try not to use attach in the first place itself. Don't even attach the data frame at any point. You can very well execute the same things with functions like with. So you can very well specify with and the data frame name, and you can very well do your activity. So this way you are not attaching, but at the same time you don't need to refer to the dollar every time. So you don't need to give the name of the data frame dollar, the name of the variable every time. So some of the mechanisms that are typically suggested when you are using the same names for the variables, data frames, different calculations, etc., where there is a possibility of masking. And regarding the input and output formats, so you can control the formatting using the escape sequences we have already talked about. /t is more for tab character, /n is for a new line, /r is for a carriage return, etc. And if I want to really check the files from the command prompt, if at all a particular file exists, so let me just check that file.exists. I'll give the name of a file, right? This whole thing. I want to really check if this file exists. So there is one more, this is a simple format which gives me a true or a false, saying whether the file exists in that location or not. If I change the name a little bit, I get it as false, saying that this particular file does not exist in this particular location. Now, if I have to read dates and times from the files, of course I'll take it as a separate session altogether. We have to be very careful when dealing with the dates and times for any kind of computation purpose. By default, when you are getting it from a CSV file, the dates and times are read in the form of character strings. We have different kinds of functions like strip time, or even we will talk about different functions like as.date, which would convert the character string into a date format and a time format, right? So you have to really specify what is the format in which your character string is present, so that these functions will typically convert the date and time which is in the character format into the actual date format. So these are some of the important points that you really need to remember when you are trying to read the data, when you are trying to clean the data from any of the file sources into your R. Then moving toward the next aspect, the different built-in data files. If I want to know the different kinds of data files that are available here, I'll simply say data. If I'm putting the data, it will give me the list of all the files that are present in the package data sets. I'll get list of all the data sets that are available in this package data sets. But if I want all my packages, right? So I can very well set package equal to dot packages all dot available equal to true. So if I just say package equal to dot packages, which is all packages. So within this, I want to give all dot available equal to true. Now this will give me all my available packages within all the available packages. Whatever are the data sets that are available, I will get all those data sets. Now if I have installed so many packages on my system, it will spend some time try to search all the packages that are there in my system, and from each of the packages it is going to retrieve the typical file. Now you see in the package ACSWR there are so many data sets that are there. In ActuR package there are some data sets. In AgriCole package there are some data sets. In AgriDat package there are some data sets. So different, depending on the different kinds of packages that I have installed on my system, I could see different kinds of data sets being present. So in all my packages, whatever are the data sets that are present, they all would be typically read. And if I want to know anything about a particular data set, right, let me again get the data. Let's say I want to know something about this particular data set called air passengers. I'll simply put a question mark and put air passengers. I'll get a help. Just like any other function based help, even for the data sets I can get the help. So it's a classic Box Jenkins airline data. Monthly totals of international airline passengers from 1949 to 1960. So this is what is specified as a part of this particular data set. So you'll have an understanding of what this data set is all about. So by doing a simple question mark. And even when you are putting a try on the top of it, so even if that name of the package is not available, so let's say if I want to do data of package equal to mass. So from the mass package, it will try to give me the data. Okay, I need to put data. So these are the data that are present as a part of the mass function, mass package. But if I use on the top of this a function called try, right, in case the package is not available also, it will move further to the next in the list. So that's the reason we can use try function, especially if you see that there is a possibility of one of the packages missing. It can do a kind of a error handling. So that is one of the reasons. Sometimes just rather than simply typing the data and package equal to something, I can very well set try on the top of it. So even if you want to attach the data files, just like the way you have attached the data frame, you can attach the data files also. And once you have attached them, the variables can very well be accessed by their names as such. Then this thing we have already set, right? We have got the working directory. So we'll look at the working directory. We have already accessed it earlier. Right, I'm getting the working directory. So this is telling me that this is the working directory. And if I want to know the base name, right? Probably let me take this whole path and say base name. If I'm using the function base name for this whole path, it will just strip off the whole path and only give me the name of the file. So from a particular path, if I just want the name of the file, I can use the function as base name. Similarly, if I say dir name, which is the name of the directory from the whole path, it will give me the whole path except the name of the file. Right, it will simply give me the whole path. If I say dir name, it will give me the whole path except the name of the file. If I say base name, it will give me the name of the file itself. It will not look at the name of the path. So, or sometimes if you have all different aspects, you can let's say each one pointing out to something different. A is C, right? C colon. B means some XYZ. C means ABC. Now you can say, you can specify all these things and separate it with a double slash and say file.path. The path would be created like this: C double slash colon XYZ double slash ABC. So it finally gets created like this. So you can even create a file path through this function called file.path. If you have the names of the folders, you can very well create a file path using this file.path kind of a function as well. So some of the important things, especially when you are reading the data from some other sources, you may have to create these kind of things. You may have to understand your working directories and all that kind of stuff. Now, the next thing that we are going to look at is reading the data from an external database. Now, if I have to look at any external database and I have to typically read the data from it, the mechanism that I am following is Open Database Connectivity, which is otherwise called as ODBC. And just for people who don't understand the ODBC as a concept, it's a standard software which is typically used for as an interface to access any kind of DBMS. So we are independent of a programming language, the database system, operating systems. So this is the advantage of ODBC connection. When I say I am creating an ODBC connection, it's a kind of a software wherein any of my programs can connect to any DBMS. So there is no language dependency, the DBMS dependency, or even the OS. Even on Windows or Linux or any other kind of OS also, I can use the ODBC to connect to any kind of database management system. So any application that we are creating, so now we will talk about R connecting also to any database. Any application can use ODBC to query the data from a database, right? So we are able to connect to the database irrespective of whatever the platform we are talking of, Windows, Linux, any kind of DBMS that it is using, Access, SQL Server, Oracle, anything. So the way it accomplishes is there is a driver, right? And so for every kind of a database, we talk about a driver which act as a translation layer between the application and the DBMS. So through R, if I have to connect to my DBMS, there will be a driver. This driver will act as a translation layer between R and DBMS. So the application really need to understand the syntax regarding the ODBC and the driver related information. So that query would be passed to the DBMS in the language that it can understand, and the kind of information that is returned, the data that would be returned, is in a format the application can understand. So that's the kind of role that would be performed. So the ODBC syntax as well as the name of the driver needs to pass the query to the DBMS in the language that DBMS understands. The data would be returned in the format the application can understand. And all the communication with the database happens using SQL. Right? So for the purpose of this, we will first we have to create a DSN, which is called as a data source name for our computer. Whatever is the data source, we have to create it on the system. So let's say I am using one DBMS, one data source which is called as Northwind database, which is an Access database, right? So that I have stored as a part of my folder. So I want to connect to that particular information. So I have to really go to my computer and do this kind of initial setting before I start using the R. So let me get into my C drive. I'll go to Windows. Then within this I will access this folder syswow64. Within this I'll have a file called odbcad32. I'll open this odbcad32, which is the data source administrator. So we have all these databases that are already connected, right? So it is having DBase files, Excel files, MS Access database, Visio database samples. So I can very well add my data source. Right now I can look at these are the user DSNs. So I can very well do add a data source. So I could look at the Microsoft Access driver and I will click on finish. I'm adding a new Microsoft Access driver. So then I'm getting the ODBC Microsoft Access setup. I want to give the name of the file. So this is the name of the file that it is, the Northwind. I can give some kind of a description, right? Working with R, some kind of a description. Then I have to select the name of the database. So I have to go to that location. It is there as a part of my H. So it is there as a part of my H drive. So I'll try to select my database from this location, training videos. Then I have our data sets. Right. It's not present here. The MDB, because it could be .accdb kind of a database. So let me just check that out. Or if I say all files, I'll use northwind.accdb, right? So I'm selecting that database, and if I say OK, so I see that my Northwind database is added here, and I can do an OK. My overall thing is completed. Now I can very well do an accessing of. So now this is set up a ODBC connection to this particular data source. Now if I have to do this access from R, right, this particular data source, so first I have to make a ODBC connection, then I have to install the package RODBC, so which is more like it would be connecting R to a ODBC database. So let me try to install that package RODBC. Okay, so RODBC is the name of the package that I am installing, and at the same time I would also load this package. So I'll do a library RODBC. So the same package I have installed and then loaded, right? Then I am using this function called ODBC connect. ODBC connect is the name of the function, wherein I'm telling the channel through which it can access the database. So I'm giving the ODBC connect. So let me call it as the name of a channel. I'll use the function as ODBC connect and the name of the database. So I'll give it as Northwind. That's the name of the database we are talking of. So you could see, yes, the database is accessed. So I need to give this is not an MDB database. So let me do another connection of ODBC. Now let me try opening a fresh connection. I have a ODB, I have a MDB file now. So let me go to Windows, right from where I can very well look at sys wow 64. Then I'm going with ODBC AD32. I'll add a new DSN. If I'm looking at adding a DSN, so let me add Microsoft Access driver. The data source name, let me give it as Superstore. I have one more data now. Right, working with R. I'm having an MDB database now. So I'll go to H, my videos location. Now I have an MDB file. So let me connect this MDB file directly. Now there should not be any kind of a problem. Right, when I say OK here and I say OK here, now my database need to be connected. So let me now see if I can connect using this ODBC connect. Let me see if I can connect Superstore. Yes. So my MDB, using my MDB database, I'm able to connect to this particular Superstore. Right. So that's the first step. Then, so I'm able to now communicate with the database from R using my SQL command. And the way I do that is I create, so I have to use a function called SQL query where I'm talking about a channel and a query. Right, I have to talk about the channel and the query. So the query is one of the tables from which I may have to get something. So I can create that as a data frame. Right, so that's the typical way I get the data. So, but I need to know what is there as a part of, what are the tables that are there as a part of that database. So let me just quickly look at that. So one of the tables that I have there is the table by name data. So what I can very well do is I'll execute my query now. So I'll create a simple the base query. wherein I'll set it as, so select, right, the select I have to give it in caps, select star from data. Data is the name of my table. So this is the query that I am creating, and I'll create a new data frame which will pull the things. So it will use the command SQL query, wherein the channel name is the channel, which is the name of the data source, DSN name from where I have to get it, and I'm giving the query. So I got my DF, which is, it has executed the query. You could see now DF. This is the whole data that is there as a part of DF. The whole thing came as a data frame. So you can talk about head of DF, wherein it is saying category, order date, sales, all this kind of stuff. So it has pulled in some kind of data as a part of your query. Now query wise, this is how you can very well work around. So you need to be comfortable with the way you create the SQL query. So you have a select statement which talks about a list of variables that you require. When you are putting star, you are getting all the variables. But if you want only a subset of those variables, right? So probably if I want only the sales or some such kind of stuff, then you can give the name of the components itself. From is the name of the table containing the variables. You can specify where, talks about which rows of tables are required, right? If I typically specify where the sales of sum is greater than 10,000, right? The same thing. Now let me update the query where sales sum greater than 10,000. So if I say this is the name of my query and then I put df, now you look at your df, it will undefined function sales. Okay, you have to get your sales, where sales, not sales sum. So let me put my query as where sales is greater than 10,000. Now let me see if I can execute this. Yes, this got executed. df, now it's still saying the same. So when I'm using my where query, let me just check sales. So it's not able to do the query properly. Could not SQL execute direct select star from, so it could not execute. So otherwise I'll change the query name. Instead of putting the sales, I will try to put it as where category is looking more simpler. So let me put where category equal to where category equal to, I give the name of the category, right? Let me set it as technology and I'll put the double quote, right? Where category equal to technology. Now let me check if this is working. right? I can very well look at my df now, right? Just now at least, so there is some problem with the name of the variable. So I have to be slightly careful in terms of giving the names of the variables so that I can very well access them quite comfortably. So before I pull them into R, I have to set the names of the variables right. But this is the way you can access the stuff. So basically you are using where clause. Sometimes you can join, wherein you can combine two tables, right? And you have to specify on what variable you are trying to join. So these are all your SQL queries. You can do a grouping by. So you can do the grouping based on some of the columns. What factors to act as a grouping variables you have to give. Having is a kind of a field that you are going to use in your SQL query, wherein talking about conditions applied after grouping. So these are all your SQL command. Order by, sorted on which variable. Limit offsets are typically counts. So all these things you can include as a part of your SQL query. And once that SQL query is given, you can very well create a query statement, which is a kind of a string variable or a character variable, which you would be passing as an input to SQL query as a function. So you have to give the name of the channel or your ODBC connection, data source, DSN name, and that would be one input. The other input is the query that you have created. So you will create your SQL query, give that as a typical input to the SQL query formula function. That is what will try to extract the data in whatever, based on whatever the query that you have given to the access database, from which the filtered query would be retrieved into a data frame. So you can very well work on your data frame and very much produce the results and graphs whatever from the access database. So so accessing the access database or SQL Server database, all of them happen in the same way. You have to create a ODBC connection, and after that you are using ODBC connect from the R ODBC package. The ODBC connect will access the database into R, and after that you are using your SQL query command to typically bring the data from the database into R, and that data comes as a data frame. After that you can manipulate the data in R quite comfortably. So these are the different mechanisms in which you are able to read the data, provide the input data in R. You can read it from the keyboard, you can read from files, you can use scan, you can use readLines formula, right? And we can even read the data from the database as well. Along with that, there are a lot of data files that are present as a part of each of the packages. So these are the different sources in which you can read the data in R. So once you are able to read the data from the appropriate sources, then you need to focus more on manipulations of the data. So this is what I wanted to talk of as a part of the inputting of the data into R. If you have any further queries, you can get back to me by giving me a call on the number that I have given below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.